Okay, numbers 13 through 16 says verify the equations are inverse with the given domain restrictions. With the given domain restrictions. So, first things first, there are two things with these that I need to check. First things, I need to check A, does the negative root jive with the domain restriction? And if it does, I will go back and check to see if that fits what they gave me. Okay? So, first things first. Remember, if I want, if it's a greater than, that means I want that side. So if it is greater than sign, that means I want the positive root because it's going to positive infinity. If they give us the less than, go away, less than, I can do better than that. If they give us the less than, that means it's going to negative infinity, and we want the negative root. So like this one right here, it says greater than, so we want the positive root. However, they put a minus in front of the root. So this is the portion that goes to negative infinity. Okay? They don't jive. Another way of looking at this, if I plotted that equation, it would look something like this. And what they wanted was this right-hand side. Okay? That's the part of the positive infinity, which means you would get that side as your inverse. However, since it's negative, what they gave us was this side. So this one don't jive. So the answer is no. They don't fit. Okay. Number 14, same idea. They wanted x is less than infinity, less than 0. So it's going to negative infinity, which means they want the negative root. So they gave us the negative root. So based on that alone, I can say this is likely. From here, we'll try again. So switch your x and y and see if it works. So we're going to go x equals 3y squared plus 6, and resolve. So move the 6. X minus 6 equals 3y squared. I'll divide by the 3. Let me go over here. X minus 6, divided by 3 equals y squared. And then one more time, we'll take the square root of both sides. So square root of x minus 6 over 3 equals y. Now, you might think that that does not work, but remember, this is like having two fractions. You got an x over 3 and a negative 6 over 3. So what this really is the square root of 1/3 x minus 2 equals y, which that that is what is over here. Now, they wanted the negative side, so we got the negative up there. But that is what they looked for. So therefore, these two are inverses. The answer is yes. Okay. 15, 16, same idea. Let's check to see if they've matched first. Oh, actually, I want you to try it. Go ahead and try 15, 16. Pause it and try it. All right, we're back. They want x is less than negative 2, so therefore they want the negative infinity side. So you need a negative root. Well, they gave us a positive root, so therefore you can already tell you right now this one's no. Okay, number 16. Pause it and try it if you haven't done that yet. So here we go. X is greater than 0, so therefore they want the right-hand side of the equation. They want to positive infinity, which means you want a positive root. Well, they gave us a positive root, so it already passes that test. Let's just go ahead and figure out if these really are roots of each other. So rewrite it. I'll do the top one. It doesn't matter which one I do, but I'll do the top one. So that is x equals 2 parentheses y minus 5 squared. So we'll divide by 2, so that's x over 2 equals y minus 5 squared. Take the square root of both sides, because remember, to get rid of a square, you got to take a square root, which they wanted the positive side, so we're going to make it a positive root. So that is a positive x over 2 equals y minus 5. And the last one, at least, we'll add the 5. So that is x over 2 plus 5 equals y. And that's your answer. Okay. So the answer is, for this one, is no. They are not inverses. While, yes, they both have that positive side of the equation. This one's the greater than, and they give us a positive root. However, when I took the inverse of that one, it did not match my other equation. They're similar, but they're not the same. Okay? There you go. If you still just want to try it, a good way to study is just cover it up or write the equation somewhere else and just redo it until you get good at it.